Kia ora, and welcome to Maths with Kirin. We're up to lesson number 5. So today we're looking at linear equations and inequations or inequalities, whatever you'd like to call them. So these turn up quite a lot in old exam papers. So usual format today, I'll go through a few examples of these with you, and then I will look through, I think I've got 5 questions from just the 2019 and 2018 papers. So I can go through those with you and talk about the sort of way that they're marked as we go. So we're just going to get straight into it. So solving linear equations, we want to isolate the variable. So quite often in maths it's an x, but it doesn't have to be. It could be any letter. And so we just want to isolate that variable. So we sort of think about getting that on one side of the equal sign and all of the numbers on the other side of the equal sign. And once we've done that, then we can figure out what the value of x is. So for this first example, the first thing we'll need to do is expand everything out so that we've got all of our terms, and then we can start rejigging things so that we've got variables on one side and numbers on the other. So our 4x will stay out in front. And then we are minusing 2x. We are minusing negative 8. So just be careful with that one. Minusing a negative 8 means that we're actually adding it, and then that's going to be equal to 5 plus 10x. From here, we want to tidy up this left-hand side, and then we'll start to do our sort of moving across the equal sign. So if we've got 4x and we take 2 away, we're left with 2x plus 8 is equal to 5 plus 10x. So there's two ways, or two common ways that people do this. Some people like to always just move the x terms to the left-hand side, and some people like to sort of manipulate it so that they have a positive x term. In this case, because we've got a 2x on the left and a 10x on the right, if we moved our 10x across, we would need to subtract it. We're subtracting it from both sides, which would mean that we get a negative 8x on this left-hand side. If you wanted to have a positive x, because you feel more comfortable with that, then some people would move the 2x to the right-hand side. So you'd have 10x minus 2x. It doesn't matter, it's personal preference. I tend to move things to the left. And the other thing that some people do is they switch, because these 2x plus 8 is equal to 5 plus 10x. Sometimes people will rewrite it, so 5 plus 10x on the left-hand side is equal to 2x plus 8. It's personal preference. So I'm just going to go through and move our x terms to the left. So we want to subtract our 10x from both sides. So if we've got 2x on the left and we're subtracting 10x, we've got negative 8x. We've got 5 on our right-hand side. With this 8, we want to take that away, so we don't want it on the left-hand side anymore. So if we take it away from the left, we take it away from the right, and 5 minus 8 gives us negative 3. And then to find x, we need to divide through by negative 8. And if we've got a negative 3 divided by a negative 8, that's actually positive 3/8. And you can leave it as a fraction. There's no reason to turn it into a decimal, just leave it as 3/8 and you're done. Our second question here is this one fraction equals a second fraction. So what we want to do is not have these denominators anymore, because it makes things a bit easier. So this left-hand side is being divided by 3. To undo that, we need to multiply the right-hand side by 3. And then likewise, this right-hand side is being divided by 2. So to undo that, we want to multiply the left-hand side by 2. So we're going to do that at the same time, because we're clever. So this 2, if we're multiplying this whole fraction by 2, it really just means we're multiplying the numerator by 2. So we're going to bring our 2 out in front and multiply it by 5x minus 2. And that's going to be equal to bringing our 3 across and multiplying by the numerator on our right-hand side. Now, because we've multiplied this by 2, that has disappeared, and we've multiplied this by 3, so this 3 has disappeared. So we now don't have any denominators to worry about, and we can just expand and solve like we did with our first example. So this only works if you've got one fraction equals another fraction and there's nothing else. You don't have a 5 or something at the end of any of these. So expanding, we get 10x minus 4 is equal to 12x plus 3. Moving our x's to the left, we've got 10x. If we minus 12x, we get negative 2x. And then plus 3, and we want to add 4 this time. So 3 plus 4 is 7. So negative 2x is equal to 7, which means x is equal to negative 7 over 2. Okay, so we're dividing through by negative 2, but you can just take that negative out in front. So we know that if we're dividing a positive number by a negative number, then our result will be, okay. So that's that second example. And example number 3, a little bit more tricky. We've still got a fraction here. So we've got 8x plus 1 minus 4x over 8, and that's equal to 7. So again, probably best to deal with this 8 first as the denominator. So we do want to multiply everything by 8 because multiplying this by 8 will mean that we don't have the denominator anymore. That means that we need to multiply this by 8 as well as the 7. Okay, so the common error with this kind of equation is that people remember to multiply the 7 by 8, but they forget this one here. Okay, so just try and remember that. So 8 times 8x is going to give us 64x. 1 minus 4x is just 1 minus 4x because we're multiplying that whole fraction by 8. And that's equal to 56. 7 times 8 is 56. Perfect. We want to tidy this up. So 64x minus 4x is just going to give us 60x. Plus 1 is equal to 56. Moving our 1 across to the other side, we want to subtract it. So 60x is equal to 55. Okay, so x is equal to 55 over 60. Now they both have a common factor of 5, so we can simplify that to 11 over 12. Okay. In your MCAT assessment, quite often with these kind of questions, if you leave your answer as 55 over 60, you get your marks for that. You've done all of the algebra stuff to get that far. It's just the simplification stuff that you've done. But always good practice to simplify. So make sure that you do look for that to get a fractional answer. Perfect. So now we're looking at inequations or inequalities. These are solved in pretty much the same way as if you were looking at a linear equation. The only difference is if you are multiplying or dividing through by a negative number, you need to flip the inequality sign the other way around. Okay, and if we just sort of think about why this might happen, we can agree that 2 is less than 5. If we multiply those by, say, negative 2, we get negative 4 and negative 10. Negative 4 is not less than negative 10. That's wrong. Negative 4 is greater than negative 10. And so because we're multiplying by this negative 2, our inequality reverses. And that's because if you think of our number line, we sort of have 0 in the middle. We have all of our positive numbers going up, and then we have all of our negative numbers going down. It kind of flips. So when we're multiplying by negative, the bigger the number part, the smaller the number. Whereas if we're looking at positive numbers, the bigger the number, the bigger the number. So that's why that happens. Otherwise, you just treat it exactly the same as a linear equation. So we'll go through 3 examples, and then we'll look at these exam questions. So this, similar to the first example with our linear equations, it's just that we have an inequality. So expanding out, we get 2 minus 3x, and then we are minusing 3 times 4, so we're minusing 12. That's still less than 17. Tidying this up, we have our negative 3x. 2 minus 12 is negative 10. Less than 17. Moving our negative 10 across, we're adding 10. So we still have our negative 3x. Inequality is still pointing to the left, so we are adding 10. So that gives us 27. And now we're going to divide through by negative 3. So because we're dividing by negative 3, we need to flip the inequality. We get negative 27 over 3, which we can simplify to negative 9. Okay, so x has to be bigger than negative 9 in order for that to work. And you can, if you want to check, substitute in negative 9, substitute in negative 8 if you want to check and make sure that that's going to work. Okay. Question 2. We've got negative 2 is less than or equal to 9 minus x all over 3 plus 4. So again, we could multiply by 3, but you might want to move the 4 first because this doesn't have an x. If we move it to the left, we can simplify straight away. and then we can deal with that 3. So bringing our 4 across, we need to subtract it. We've got -2. If we're subtracting 4, we get -6, less than or equal to 9 minus x over 3. Now we can bring our 3 across. It means that we only need to multiply one thing by 3. So we get -18 is less than or equal to 9 minus x. Bringing our 9 to the left-hand side, we need to subtract it. So subtracting 9 from -18 is going to give us -27. And that's less than or equal to -x. So we need to multiply both by -1 or divide by -1. Get the same result either way. So that means that 27 is greater than or equal to x. Okay, and if you wanted to write your x on the left-hand side, this is a perfectly acceptable answer. You don't have to change it. But if you did want to change it, you put your x on the left, you'll notice that the pointy side is pointing to x, so we need to keep that the same. Okay, so x has to be less than or equal to 27. Cool. One more example. So this one here, we've got 4 plus 2x over 3 is greater than 12. So again, we can move our 4 first, move that over and simplify. So we're just left with 2x over 3 is greater than 12 minus 4, which is 8. Multiplying through by 3, 2x is greater than 24. And then dividing through by +2 means that x is greater than 12, and we don't need to switch our inequality because we haven't divided or multiplied by a negative number. And we're done. Cool. So we're going to have a look at some exam questions now. I've got 5 of them to go through with you. 4 of them are actually from the 2019 paper. So that particular paper had quite a lot of solving linear equations. You can expect that you'll need to write the equation, so they won't necessarily give it to you like this. In most instances, you'll be given some context, maybe a diagram, and you'll need to form and solve your equation from that particular information. There is a question from last year's paper that doesn't require you to form the equation, and I'll show you that obviously when we get there. That one is a little bit tricky in that it doesn't look like a linear equation to start with, but it does end up being a linear equation. So this is from the 2019 paper, and we did look at a part of this question in the simplifying terms video. So same garden, we're looking at the lawn, we've got a garage and some flowers, and in this particular part of the question, it's telling us that the perimeter of the lawn is 290 meters. We want to find the value of x, and it says, note the lawn does not include the shaded garage or the flowers. So the perimeter is the distance around the outside of our lawn. So there's kind of 2 ways that you can do this. One is probably going to be a simplified for you, and also reduces the risk of making some errors, and that's to think of this side here we know is 8x plus 3. We want the perimeter of the lawn, which means we actually only want this bit, but we also want this bit here. And so if we take this and we add this, we're actually going to get 8x plus 3. And then likewise down here, we want this bit and this bit. And if we add those together, we're also going to have 8x plus 3. So this and this and this and this is actually going to be 2 lots of 8x plus 3. And then we can sort of do the same thing for this part down here. So if we have this and this, that's the same as our 6x plus 2. Okay, and then the same here, this and this bit here is also 6x plus 2. So we want to add 2 lots of 6x plus 2 to our equation. And we know that the perimeter is equal to 290. So we've formed our equation. Now we just need to solve it. Okay, so from here we can expand out. So we get 16x plus 6 plus 12x plus 4 is equal to 290. 16x plus 12x, well 10 and 10 is 20 and 6 and 2 is 8, so we've got 28x plus 10 is equal to 290. Bringing our 10 across to the left-hand side, 28x is equal to 280. So x is 280 divided by 28, which is 10. Okay, and we're done. The other way that you may have tackled this question is to break all of these bits into their individual parts. And so to find this part, you would have had to go 8x plus 3 minus 3x minus 2. Okay, and that would give you this bit here. This bit here would be 6x plus 2 minus x. Yep. To find this bit down here, you would have 8x plus 3 minus 2x minus 5. And this bit down here would be 6x plus 2 minus this bit here, which is 2x plus 1. So you'd have to simplify all of these things. And then, so for example, this would be 5x plus 2. This would be 6x minus 2x is 4x. And then 2 minus 1 is 1. So that would be 4x plus 1. This down here would be 8x minus 2x, which is 6x. Then 3 minus negative 5 is positive 8. Okay, 3 plus 5. And this would be 8x minus 3x, which is 5x. And then 3 minus negative 2 is positive 5. Okay, and then you would write your equation 3x minus 2 plus 2x plus 1 plus 5x plus 5 plus 5x plus 2 plus 2x minus 5 plus x plus 6x plus 8 plus 4x plus 1. And that would equal 290. So you can do it that way. It's a little bit more labour intensive and obviously will take you a little bit more time. And with these sort of subtracting negatives, it does leave a little bit of room for error. Okay, so if you do have a rectangular shape, you might be able to do what we did up here, just to make it a little bit easier for yourself. Okay, so the marking for this question, to get achieved, you need to establish an expression for the perimeter. So you need to come up with this, or 5x plus 5 plus 5x plus 2 plus 2x minus 5 plus x, all that. If you come up with that, then that's your achieved. You may forget to write equals 290 and they'll still give you the achieved mark for that. Okay, the other thing that might happen is, say you made an error when you were simplifying some of these, so your expression for the perimeter is slightly incorrect, but you then consistently solve that expression and get an answer for x, that will also give you achieved. If you come up with the correct equation and show you're working to get x equals 10, then you get merit. Just a note, the paper is obviously an algebra paper and they expect you to use algebraic techniques. So if you just write x equals 10, then you may not get any marks for that. You can, in a paper, quite often have one instance where you just have a correct answer only, and you may have used guess and check. So to get full marks and throughout your whole paper, just make sure that you are showing the equation and a little bit of working in order to get that x equals 10. It's really important. Cool. Next question, also from the 2019 paper. So this time, again, we had to write our equation. So Mary gives some clues so that her secret number can be calculated. She says, when 20 is divided by my secret number, and then 7 is added to this answer, this gives a solution of 2. What is Mary's secret number? So again, it's not instructing us to write the equation, but we need to do that to get full marks. So when 20 is divided by my secret number, so let's say the secret number is x. When 20 is divided by my secret number, and then 7 is added to this answer, this gives a solution of 2. So form the equation, now we solve it. So moving our 7 across first, 20 over x is equal to 2 minus 7, which is negative 5. Bringing our x across, 20 is equal to negative 5x. Dividing through by negative 5, 20 divided by negative 5 is negative 4. So x is equal to negative 4. For this question, you have to form the equation and solve it, and you can get achieved. Okay. third one, also from 2019. This one's an inequality, and it just simply tells us to solve the inequality. It's given us the equation, we don't have to write it. It's given us the inequality, I should say. We don't have to write it. So we can just go about solving it. So expanding, we get 30 minus 12x. Minus 4 times 5 is minus 20. Minus 4 times minus 3x is positive 12x. Is greater than 5x plus 20. Tidying up this side, and we've got 20, and then we've got 30, and we minus 20, so we get 10. Negative 12x plus 12x, well, that's no x, so we're just left with 10 is greater than 5x plus 20. Bringing our 20 across to the left-hand side, we need to subtract it. 10 minus 20 gives us negative 10 is greater than 5x, and then dividing through by 5, we get negative 2 is greater than x, and if you wanted to write that the other way around, you'd get x is less than negative 2. Okay, so for this question, if you get all the way through and you either have negative 2 is greater than x or x is less than negative 2, that gives you merit. To get achieved, you either correctly expand all of the brackets, so you get this far, or you consistently solve your inequality, but you may have done something incorrect in your expansion. So, for example, you might have gone negative 4 times negative 3 is negative 12x. Yeah. If you did that and then consistently solved your inequality, you'd obviously get a different answer, but you can get achieved for that. Or if you inadvertently write your answer as an equality, so you write x equals negative 2, then you would get achieved for that as well. So if you go through and solve it with you can still get achieved for that question. Cool. We've got 2 to go, and then we're done today. So this one, again, from 2019 paper. So this is asking us just to solve the equation, and it probably doesn't look like at first glance we're actually going to end up with a linear equation, but we will. So this is one fraction equals another, and we looked at one of those when we were doing the examples, the second example that we went through today. So same process applies. We want to take out x plus 4 and multiply it by the numerator on the right hand side, and we take out x plus 2 and multiply that by the numerator on the left hand side. So we get x plus 2 times x plus 12 is equal to x plus 4 times x plus 4. From here, we expand. So this side will give us x squared plus 12x plus 2x gives us 14x, and then 2 times 12 is 24. That's equal to x squared plus 8x plus 16. You'll see that we've got an x squared on both sides. If we take an x squared away from both sides, then they actually just essentially cancel each other out. So we are left with 14x plus 24 is equal to 8x plus 16, linear equation. Bringing our x to the left-hand side, if we've got 14x's and we minus 8x's, we get 6x. And then 16 minus 24 is going to give us negative 8. Okay, so 6x is equal to negative 8. So x is equal to negative 8 divided by 6, which we can simplify to negative 4 over 3. Okay, and that's it. So for this question, if you get all the way down either of these, so x equals negative 8 over 6 or x equals negative 4 over 3, that's merit. For achieved, you have the correct expansion and arrangement of both sides, so you get to here, okay, with your x squared, obviously. Or you have a consistent solution, so maybe you do something incorrect when you do your expanding, but you can consistently solve that. Then you can get achieved. Or you consistently simplify your expression. Okay, so those are the ways that you can get achieved. If you get all the way through to either x equals negative 8 over 6 or x equals negative 4 over 3, then that's merit. Okay, and the last question for today is from the 2018 paper. So this paper didn't have as many linear equations to solve, but it did have some quadratic ones. So this is an example, obviously, of a linear equation that we want to have a look at. So we have a house-shaped model, we're given a diagram. The perimeter of the model is 32x minus 7, and they're asking us for the length labeled AB. So we're going to form an equation. We're going to solve it as best as we can. So I'm going to start with AB. So we know the perimeter is obviously all the way around the outside, and we're given all of the lengths, so we just need to write them in. So AB plus 4x minus 2 plus 8x plus 3 plus 6x plus 5 plus 10x plus 1 is equal to 32x minus 7. Okay, quite tricky to fit on there, really long line, so we're going to simplify this. And I'll bring my, normally convention is to write our equal signs in line. I'm just going to bring it to the left a little bit so it's a bit easier for us to read. So we've got 4x. If we add 8x, that gives us 12 plus 6 takes us to 18 plus 10 gives us 28x. Negative 2 plus 3 is 1 plus 5 is 6 plus 1 is 7. So 28x plus 7 is equal to 32x minus 7. Okay, so we want an expression for AB. So we're going to move both the 28x and the 7 to the right-hand side, and we're just going to have an expression for AB. So AB is equal to 32x. Bring our 28x across, we need to subtract. So 32 minus 28 is 4x. Negative 7, when we bring our positive 7 across, we subtract it. So negative 7 minus 7 is negative 14. That's as far as we can go. We don't have any other information in order to solve for x or to get a simplified expression for AB. So we just get AB is equal to 4x minus 14. So for that question, again, it's a merit. So if you sort of write out your initial equation and simplify down to our AB equals 4x minus 14, that's merit. For achieved, you can establish your relationship. So this line of working, you need to make sure that you have AB in there in order to get that achieved mark. Or if something goes wrong, you incorrectly write something, or you could have tried to simplify as you go and go straight to the step, but you get something wrong. But you then consistently solve your equation, then you can get achieved as well. Okay, so lots of those solving equations, all but one of them were actually merit level, so long as you wrote your equation and then solved that. There was only one of those examples that was an achieved question. Perfect. So I hope that was helpful. Gave you a little bit of a rejig of solving linear equations. On Wednesday, I'm going to go through solving quadratics, okay, and I'll also look at quadratic inequations that has come up at excellence level in a previous paper before. So we'll look at solving quadratic equations, but also have a look at solving inequations. And then on Thursday, I'll come on at 5:30 and just see if anyone has any questions that they want to ask. If not, I'll not be gone for very long. And next Monday, we're looking at solving exponential equations. Okay, so that's what's coming up. If you're finding these videos helpful, it'd be really awesome if you share. So make sure you follow the page, like the page, subscribe to YouTube, and like on YouTube. If you're watching them not live, then that would be really awesome. Subscribe so you can get notifications, and share. So share with a friend, let other people in your classes know that you found these helpful, and maybe we can help some other people as well. If you have questions that you want me to answer, you can email them. So my email address is up there. Just put me an email and I'll answer those in my Thursday sessions. So if you can't watch live on Thursday and I do have a question to answer, then that will be uploaded to the Facebook page. So you can still get that question answered there. Otherwise, have a lovely evening, and hopefully I'll have some questions to answer tomorrow. If not, hopefully I'll see some people on Monday. Okay. Next.